All right. Well, how are you excited to be fixing all the things in your life? Not just vintage computers, but it starts with looking inside and keeping retro alive, because we are gonna, as Tim Gunn says, make it work. All right? So a little bit about me. My name is Stacy Devino, and normally I give a lot of talks on very technical deep dives into basically Linux systems and Android coding, to technical leadership and a lot of things around diversity and technology. But I have been personally restoring electronics since actually elementary school. I learned how to solder from my grandfather, who had an electrical engineering degree along with industrial and a bunch of other patents. So if you've ridden in an elevator, you've definitely ridden in something that he invented, or hot cold carts and a bunch of other things. And I've also been able to take those skills to fund so many of my projects and so many of my other learnings throughout my entire career. I would not be where I am in my career were it not for learning how to fix things. And so let me share with you kind of my formulas for how to pick the right things, problems to solve, and how to actually go about solving them. So with that, we're going to focus on 4 main areas today. Before you buy it, how to know what you're in for and if it's worth it. Some vintage electronics are really expensive, so that comes into the play. But sometimes it's sentimental. And sometimes you're just picking something up because you're like, oh, it's only $10. But it may not be fixable. Or it might be a very uphill battle. And we'll go into reasons why and how to recognize those. Before you ever turn the thing on, in the powered off state, before you even plug it in, what are some things we need to do? What are some things we need to inspect in order to have the best possible outcome and not potentially kill the thing before we've even run the thing? Powered on. What can go wrong? And how can you indicate some of these issues once the power's turned on? And how do we negate some of those issues that we'll find as soon as we try to see if the green light turns? And finally, make it better. How can we take our existing electronics without adding third-party boards and other things like that and actually make it so that you don't have noise on the ground floor, so that the picture isn't fuzzy, so that your processor is working as quickly and quietly and seamlessly as it possibly can? And with that, before you buy, is it even fixable? So, do I want this thing? And these are serious questions to ask yourself. Do I want to invest the time and effort required? Do I need this thing in my life? As people who collect things, these are things we constantly have to ask ourselves. Is it worth it? Am I getting this as a backup to something else in order to fix something else, or am I getting this because I'm going to fix this thing? And ultimately, yeah, it might cost $10, but it might be several $100s to fix. So you need to understand what you're signing up for, not just from a time and effort standpoint, but also money and skill. Do you have the willingness to even go about gaining the skills or spending that money? And those are really important questions, because first we need to talk about rust and corrosion. How do I identify it? Well, guess what? Some cases it doesn't matter. Some cases scientifically, okay, all right, the wrong button. Scientifically, this actually outperforms this one. So when it comes to transformers, when it comes to side rails, for the most part, Rust is not an indicator that anything has gone wrong. There's a lot of different kinds of rust and corrosion. There's galvanic oxidation. There's some things like dendrite formation, which we'll go into on some of the PCB stuff. But seeing rust isn't necessarily an indicator that something is wrong or unfixable. The biggest thing to look for is, does it look like it spent significant time underwater? Because environmental rust is just a reality. These machines, in most cases, are at least 30, 40, sometimes 50 years old now. 50 years ago is 1973. We have machines that old out there, several of them. So it's important to recognize that nobody's actually building these things to last super long time. And as part of that, also batteries. You're going to be able to see corrosion around basically any acid leaking interface. And we'll go into that on PCBs. But if you see a bunch of corroded batteries or batteries that are present in the actual item, and there's stuff all around them, you could be signing up to do some significant work. Sometimes that work is not as difficult as you might imagine, but really you want to look for this kind of buildup of this almost crystalline structure. All right, so now on the PCB itself. This is a Commodore 64. How many of you have seen this? Do you know what actually is happening there?
Yes.
What's going on?
The solder mask is not over bare copper, it's over tin plated material. So when you put it through the wave, it reflows and it causes the mask to crinkle.
Yeah, so this is actually just there's two things that can happen. This is one example of that. So this is part of the wave soldering method that they actually produce these PCBs for. So these were single side etch PCBs. So they literally plated them with FR4 with copper, etched them, and then literally threw them in a machine, in a pile or bucket of solder. And then they pulled them out and tried to coat them. And so you're going to just see some lifting and things like that because it was all part of the process itself. So while it didn't look like this originally, this actually isn't anything to worry about until you see physically lifted traces. And you can actually stop a lot of the issues here with just a simple spray of some clear paint or clear coat. Triple thick's popular, a bunch of other ones are popular, but you can inhibit some of the further issues there. So this is not necessarily a problem, even though it looks scary. This doesn't look that scary, but is a problem. Yes?
You can also get that effect using canned air because it's so cold. So
I'm sorry?
Canned air. So if you're using canned air, it's cold because it comes out, depressurizes, and gets real cold, and it'll crinkle it also.
Yeah, it will. So that's why I also say it's a good idea to coat it, because the issue with this one at this point is mechanical failure, not necessarily electrical failure, right? It's a mechanical failure that causes an electrical failure, right? But this is scary. This is scary for a few reasons. This is a ton of micro corrosion combined with what I can see is some sort of leaking residue. And every one of these joints is a cold solder joint. So this looks scarier on the outset. This is actually scarier to fix. And I'll go into how you can fix these. Like this is not in terrible shape. This is in somewhat fixable shape because of how thick the traces are. but it's more work than you might think it is. Because you might be thinking, oh, this is just dust. No, that's rust. And then the unobtainium. Are there any parts in the thing you're trying to fix that are things like key switches, membranes, and keycaps prior to about 1988? So an example that you wouldn't think would be hard, these are long pole Alp switches from an Apple II, original Apple II. You can't find replacement keycaps. You cannot find replacement switches. The only replacement switches come out of other people's Apple IIs. And that's if they're extremely gracious. And that's also assuming that the internals haven't broken. Most of the time they haven't, but you can maybe redesign and 3D print this, but that's a lot of work. You're gonna spend at least 20 hours dealing with this one bad switch of your life. Think about that. 20 hours, at least 40 bucks dealing with one bad switch. Membranes. So very recently, they started remaking some of the Model M membranes, so you can get brand new Model M membranes. There are a lot of other buckling switch keyboards out there. They all use an internal membrane, many of which are not as well built as the IBMs. And so their membrane is also extremely hard to clean, because anytime that you clean them, because it is a membrane of 2 Mylar sheets with traces on top of them, it's gonna potentially introduce issues. You can already see in here, we have corrosion on active voltage lines. So I'd have to go in there, scrub it very carefully, resolder it, or actually use one of the circuit draw pens and refit that in. We also have things like replacement CRTs and especially vector monitors. What usually goes bad if you try to send something through the mail is something like this, where, oh, no way I'm getting one of those plastics ever again. And more than likely, you also knock the neck. The necks have not gotten stronger over time. They've gotten weaker, and therefore they are very, very susceptible to breakage. There's also issues with ROM and RAM chipsets prior to 1981. So if you've seen 70s arcade machines, they are using chips, especially like Space Invaders, that are no longer sourceable. And they actually use like silver pins. So you'll notice them because the pins themselves outside the chipsets are actually silver or silver plated. And so those have no necessary analogs. And there's some very custom ROM and RAM chips that were done in some early 80s computers and late 70s computers that, again, something goes wrong. I hope you're really good at FPGAs. How's your VHDL or Verilog skills, everybody? And yeah, so any custom rare systems, you're gonna have a really hard time sourcing parts. All right, so now you've decided, yay, I'm gonna do the thing. I'm gonna fix it. We're gonna start with cleaning. What, cleaning? And you might be thinking, oh, I gotta be all scientific here. You need rubber gloves with disinfectant. These things are old. There's been a lot of bug poop since 1982. And I have opened up machines from the late 70s and found not one, not two, but 3 dead mice. Maybe they were blind. I have no idea. But they must have been in order to have gotten stuck. So apparently that was a dead mouse graveyard. So disinfectant. Lysol? Oh, yeah, yes, dead things. Yes, gross. So in the case of that, sometimes you want to use things like medical disinfectant, but also for the most part, Lysol is going to be fine to just give a nice little mist. Make sure you're not going to die. Put a mask on. Anytime anything is dusty and old, that is very old dust with very old germs, don't take your chances. Dollar store toothbrushes. Get them in packs. Get them in multiple packs. Distilled water. Distilled water is fine for cleaning off most things. At least for getting dust and general just mechanical cleaning items off. As long as you let everything dry out, which I'm assuming, since we're this far in, we're gonna do, right? So for electrolytic fluid, leaky capacitors, Simple Green. Simple Green is basic. It's also completely plastic safe. It's great for cleaning up your plastics. And so versus like alcohol or, God forbid, taking a risk with acetone, which can scrub off stuff, Simple Green does not, because it is not acidic. It is basic. What is electrolytic fluid? It's an acid. There you go. You have a neutralizer and a cleaner. It is $20 by the gallon, and it does not evaporate like alcohol does. So for corrosion, white vinegar. You can also use white vinegar mixed with a little bit of aggregate if you need to use it as a paste. I don't generally recommend it, but just a little bit of vinegar is usually fine for most corrosion. If it's really bad, you can grab out the CLR and hit it with the Q-tips. Yes, sir.
Is that what would you use? Is that what you would use for the part of batteries that have like killed?
So batteries are acidic. So I would clean that up the same way I do with electrolytic fluid.
Okay.
Oh, sorry. For corrosion on battery, anything. So leaking out of the battery, I hit it. I always hit everything with Simple Green first, then vinegar, and then do the rest of everything. And the reason being is that I know I'm not going to cause any damage with Simple Green. If I have to be careful with the vinegar, even still, because it is an acid, so it can take stuff off. Just how like alcohol can take stuff off. So you got to be kind of
Gingerly.
Yeah, like everything, right? Yes, ma'am.
So, like computer glitches, they're called bugs because one time, like corrupted computers, someone like went and found like a dead bug in it. So they named computer glitches bugs. So I find it funny that you found 3 dead mice in a computer.
Well, you don't want to know how many cockroaches I found. Did I clean one up yesterday? Yes, ma'am. You can find them anywhere, right? And that's a great fact. It's a really cool fact. I believe that was from the late 1940s, early 50s.
Grace Hopper.
Yep. I have a portrait of her literally right next to where I work. So for metal items, Barkeeper's Friend and Mother Polish. So Barkeeper's Friend is excellent at all kinds of things, and it is stupid cheap. You can use it as a good aggregate. Mother's Polish is how you get things beautiful, shiny, pretty. And both of those can be purchased at pretty much, any Ace Hardware or Home Depot. So we've invested a whole $10 in cleaning products thus far. Woohoo! And microfiber towels. So you might be curious why I'm not listing alcohol in here. Well, the truth of the matter is that we have kind of been overusing alcohol, right? Most of the things, as long as we're willing to let them dry out, we can actually solve with simple acids and simple bases. So with regular cleaning products. And the reason why I say to kind of watch it on the alcohol is because alcohol itself can, unless you get it off and clean it off, it can actually dissolve particles that then evaporate, and it actually made the surface dirtier again. So, you know, just be conscientious of that. Alcohol has its place, has its uses. It's great at getting off like rosin and flux off of PCBs, but it's really a different part of the cleaning process. All right, so what are some basic tools I'm gonna need to actually do this work? You're gonna need a 60-watt soldering iron. Some people are like going, no, you only need a stick iron. You're gonna be doing electronic parts. You're gonna be doing potentially some like IEC cable parts and plugs and things like that. You need a 60-watt iron. You need something that's settable so that you don't burn holes through your PCBs. You need something set up to do electronic work. You can find 60-watt adjustable soldering irons for incredibly cheap. In fact, now they have USB ones. So if you want, you can pay $50 and get one that runs off the same charger as your Apple MacBook. And otherwise, you can literally pick them up for $20 to $25 off Amazon. Solder and flux. If you're not going to use lead bearing solder, which I'm definitely in the minority here, and you can fight me, Raymond Jett, in the other room. I use non-lead solder. And you're like, what? Why? Because actually, if I use silver bearing solder, which has a very small amount of silver and copper in it, I am getting a eutectic solder. It is a more premium solder, but I can keep hitting that same pad over and over and over again, and it'll come up shiny. I can't say that for the lead solder. You get 2 tries and you're done. And also, I have small children. Are you old? Are you small? Are you a person? Lead is not good for you. Be smart. Also, the same thing with your soldering equipment. Don't mix your lead soldering equipment with your non-lead soldering equipment. Just all of those kinds of things. But again, this is a different opinion than what you might actually see elsewhere. A lot of people are like, still use lead. But I don't think there's a good reason to anymore.
Do you need more heat with the silver bearing?
What?
Do you need more heat?
Just a little bit. Just a little bit. But I also tend to buy it much, much thinner with a flux core or rosin core. And it flows so much nicer though. I mean, it's just, it gets that nice little puddle thing going versus the lead solder, which I find is a little clumpier and tends to not want to have that I just welded this like beautiful polished surface. It never looks as nice with the lead solder. And electrically speaking, the silver bearing solder actually slightly does a better performance. What? Yeah. So, and that's been proven in high-end audio applications. Is it going to matter in your digital logic? Absolutely not. But good to know either way. Solder sucker and chip quick. Solder sucker you've probably heard. Chip quick might be new. Chip quick is a product that has bismuth and tin, and you use a little bit of it mixed with your solder, and it automatically gives you a very, very long working time in order to pull up entire chipsets, in order to pull up any kind of... So right now, if you tried to desolder all the little holes on like a 16 pin, 24 pin, 40 pin, so we're talking about some of the old processors, you have to get every lick of solder off every single spot. It's incredibly difficult. Versus I can throw a little bit of bismuth, stick on there with the rest of my solder, drag solder across both of them. I have a good 5 or 6 seconds of working time, and I can pull everything up cleanly. I can go back in with my solder wick and other things and clean it off. And this lets you do surface mount chips. So if you have surface mount chips, if you have surface mount capacitors, resistors, any of that stuff, because SOIC is in stuff from the 80s and TSOP, so that relatively fine pitch you can absolutely do by hand. I have video of me doing it by hand from 10 years ago. It's not hard. I did several hundred boards that way by hand. Yeah, chip quick. So, and you can request a sample, and that'll probably be more than you need for your entire project. I bought one pack 10 years ago. I still have 4 sticks left. So if that gives you an idea, and that pack was maybe like 15 bucks. So with that, you need a multimeter because you need to test continuity, more so than voltage. Remember, powered off. Solder braid, copious amounts of solder braid. Yes, ma'am.
As soon as you went into the basic tools section, I thought to myself, soldering iron.
Wow, that's pretty cool. That is awesome. I learned how to solder when I was about 8 years old too, so it's helped me out. Things you might want: rework and specialized tools, and a fiberglass pen. Fiberglass pen for being able to clear off and kind of re-level any pads or other things on your actual PCB, as well as just if you do have continuity issues, being able to expose a little spot on one trace and being able to jumper wire to the correct place. So fiberglass pen is very, very useful. All right, so how do we know with replacement? What am I going to replace? With capacitors. And this is a picture I took last week from an IBM monitor, a very specific one that you're not going to know, and it's pretty rare. So the only option is repair, right? Look at this. Look at it. Just, oh. And the whole thing was like this. And every single one of them is just like this, because we're talking about late 80s IBM, right? So what am I going to replace? I'm going to replace electrolytic capacitors. For the most part, if they are bulging or leaking. This is leaking, not bulging. If they're just old or not Japanese. So if it's prior to 1992, 1993, you probably have to replace them anyway. Good rule is 30 years or older, you gotta do it. And I've done full recap jobs on stuff from the mid-90s to the late 90s because it's been necessary. Also, if you have anything that is mid to late 90s, so you got a 1998 machine, if it's got a bunch of Chinese capacitors on there, or just not Japanese, you can see things like ITW used to be a capacitor manufacturer. Americans, unless it's Dale Vichet anything, skip Japanese. Thank you. I will take all your parts. For the most part, you're all right. Panasonic's best. You can't really go wrong with anything with Panasonic. Usually, it's going to have the M on it. It has to do with the full name of Panasonic. And then for power sections, specifically power sections, Nippon Chemicon Black. Those are the most solid large capacitors that I've been able to find in terms of performance. Rubicon, you can't really get them anymore. They could be all over the place. I have another presentation I've done, which is actually Raymond's presentation, called Bad Caps. Great one. See if you can find a copy online. Highly recommend. It's a full 1-hour discussion just on this topic. So ceramic capacitors. When would I replace those? For the most part, you don't, unless they're cracked or burnt. They are pretty stable. You shouldn't have to do anything, but very often they're cracked or they're burnt because people didn't want to use the right voltage. For film caps, Very often, paper in oil, unless it is mil spec, will have leaked. So some of your old Sprogs are usually okay, but other brands maybe not as much. And Dearborn, which was the military side of the Sprog stuff, is also usually fine. But if it's leaked, if the vacuum chamber is not there, or it's been under-spec'd for its application, which is very common, and non-sealed. So if it doesn't have seals on the other sides, it's probably not good. Wax capacitors can also go bad for the same reasons. Just degradation over time. Sorry about that. All right. And tantalum. Just pretty much always replace the tantalums. You'll see why later. Yes?
With other tantalums, or can you replace it with just regular electrolytics?
For the most part, tantalums are very expensive, so they were selected for a reason. Usually it's something to do with the ESR levels. Sometimes you can get low ESR electrolytics that will suffice, but usually they are still in the 20% band of variance, and tantalums are a little closer. So, for the most part, replace tantalums with just newer tantalums. Unless you can do some investigation and understand if you can replace them with something else. Other stuff you want to replace. Potentiometers. Very often they go bad unless they're carbon, in which case you can do the pencil trick. Voltage regulators. A lot of times these used a ton of heat and dispersed a ton of heat, caused problems all over their boards. Modern voltage regulators are much more consistent and much less heat. So if you want to keep your power really stable, if you want things to work as correctly as they could or should, replace the voltage regulators, even if it's a linear one like an LM317. Fuses and any sort of resettable fuses. So some of these systems have these resettable fuses. Please take care of those. Also, fuses are the #1 thing that'll be just degrades over time. They're designed to degrade over time. You'll see slow blow fuses and fast blow fuses. Just replace them. Slow blows are designed to fail over time. Quick blows end up failing over time just because of their mechanical design. Don't take your chances. All right, with plastics, we've all seen this beautiful yellow color. It reminds me of a sunset over Sacramento. How do you fix that? Is it worth fixing that?
Retro bright.
I kind of like a little bit of age, but I also appreciate a full restoration too. I very much take it as what am I trying to do with the thing and how am I planning to enjoy it. But if you want to, go to your local salon shop and buy this thing called Cream Developer. Get the 40, not the 20. Just throw it on there, lay it out in the Texas sun for 1 or 2 days with a little bit of coating of some plastic film so that it doesn't dry out. And what you've probably seen 8-Bit Guy do is he's got these clear plastic tubs and he just loads a bunch of hydrogen peroxide concentrate and water and just throws them outside in the tubs. That's also fine. That also works. But that takes up a lot of space. This does not. This is basically a shampoo bottle. Just don't use it like a shampoo bottle. It will make your hair, well, wider than his. It'll be, whew. So, third, powered on. Things can go wrong when it sort of works. All right, so we've been able to plug it in. What happens?
Refit caps.
Pop goes the refit caps. Pop goes the surge protector. Why? Right? So refas, you either bypass them or replace them. Depending on the application, you can bypass them. So what ended up happening, REFAs were a type of film capacitor, and they are a type of film capacitor. They're really made for AC applications, and guess what? They used them in power applications for DC, and they did so in a way that basically was trying to use them for power filtering and as protection circuits, essentially, rather than actually putting in protection circuits. So these were designed to fail in many cases. A lot of times, with our current systems and the way that we're going to be able to address some of these things, you can completely bypass them, or you can replace them. Sometimes you can replace them not with more REFAs, but proper film capacitors, depending on the application. Again, this is one of those things where people like used parts they had, so this is what happens. Resistors. Seen a lot of burnt out resistors. You know what the number one thing is? They put a 1/8 metal film resistor, 1/8 of a watt metal film resistor in a spot where it needs a 1/4 watt resistor because they wanted to use a 1% resistor or a 3% resistor, and a 5% tolerance resistor would have been just fine. Again, one of those things where people cut it close and not really think about the amount of power that's there. So a lot of times you'll see it with just kind of that burnt or smoky middle. That's a sign that needs to be replaced. If it is like that and nothing else around it is affected, it's under wattage. So that's the issue there. You need to get a 1/4 watt in place of an 1/8 watt or bump up each time. So if you have a 1/4 watt, then you need to get a 1/2 watt, whatever that piece looks. Now, older Dale Vichets, which are those brown lovelies, right? Not the beige lovelies. Those are different. Those are carbon, different. Those I've basically never seen die. So those are usually fine. What they have is just issues with some of the shells. That just happens because it's basically bakelite that's on the outside of them. And inductors. Inductors, it's usually a problem where there's a crossover somewhere in the coil. So it's not usually that the inductor has failed, but the coating on the magnet wire that's used by the inductor has failed. It's a type of enamel, which is a type of plastic. Plastic deforms and degrades. There you go. All right. Ooh, sizzle, sizzle, pop, pop. All right, we've got electrolytic capacitors. So if you're hearing something go shh. Now, you can make electrolytic capacitors go pop, but you usually do so by throwing tons and tons of voltage on. That's not what's going to happen in your application, generally speaking, unless you put a part on there that is way undervolted. And when I say about voltage with replacement and parts and things like that, I always go for 25 to 50% above spec. So if I have, you might be saying to yourself, I've got 50 volt line, 63 volt capacitor is probably fine. No, that is 63 volts peak. That's not 63 volts operational. Look for something a little bit higher. Just be safe, especially on main power line, because you might be going, oh, I've got 120 volts. Do you know how much you can spike on your regular power? I have seen spikes up to 130 volts. I tracked it on my own stuff, and I am on a super high-end circuit, so I don't have that much noise and variance. If you are connected to all your neighbors and everything else, you can see these issues. So yeah, put a 160 for a 120. Tantalums, match do. So they do. They look like little matches when they literally go up in fire. And burning up traces. This is usually because you missed corrosion. Rust plus spark equal burn. So there you go. You can end up burning up traces or bubbling up traces just from that. And winding transformers. Winding transformers are usually an indicator that something has gone very, very wrong. So usually that's a replace situation for most people. And I don't recommend custom winding your own transformer. Usually there's something that's already set for you.
I have a comment on the tantalums, just an FYI. One of the things I normally do is I'll check with an ohm meter across the power rails, because tantalums tend to fail as a short.
Yep.
And so if you turn the computer on, it will burn. So usually I'll check early, and if I see that there's a short, I'll start removing tantalums until the short goes away, and then I'll put new parts in.
Yep. That is a great experience check, and definitely solid advice. As a general rule at this point, I just kind of go, yeah, I'm just going to replace them, because I've had too many bad experiences. But if you want it, that is the correct way to do so. But yeah, absolutely. And if you have any like sage advice, please feel free to share with the group too. So kind of the next and final piece here is make it better. Fixing the lost parts or engineering issues. Yes, ma'am.
I just wanted to say, burning tantalums means burning house.
You can, absolutely. Probably, I wonder how many things have burnt down because of tantalum issues. But they're kind of expensive, so you know, being measured about how you replace them is also a good idea. So now we're gonna go make it better. So now that we've kind of gotten the thing running and we have it reasonably putting itself through its paces, or at least operating in reasonable engineering spec of how you bought the darn thing, or like would have bought it back in the day. Here's the two most important things to know about making things better. Companies are cheap. What? It is the responsibility of the company to provide the greatest profit of its shareholders. Now you can blame Ford versus Dodge back at the turn of the previous century for this one. So it is an actual law, essentially. That means that they're going to do what they do, which is engineers are going to put together things, and somebody at the company is just start removing parts until things start to fail. And they're going to look at it as process and price optimization. Right? But there's good news. So companies are always cheap, but engineers always got your back. They're always trying, right? Engineers try to build resilient systems that are robust with the ability to handle failures. Now, I can't say that for every company, certainly, right? But in a very reasonable sense, many of the times, the person designed it so that it wouldn't fail out in the field. And then mass production is what made it fail in the field, because process and cost optimizations became part of the norm. So if you take this mindset, you can go find and fix it. So here's some rules. If it looks cheap, it is cheap. For the most part, that's usually true. If something was kind of jerry-rigged or put together wrong, or seemed to be, you know, kind of whatever, it is cheap. So that's something you can quite easily recognize and usually address. And I also, if you're going to do a significant amount of these, 3D printers are great because you can redesign parts, 3D print them, and apply them. I have a bunch of mine that I've done that are on Thingiverse, and try to share as much of that as I come into it. But a lot of times, people are just working with the parts they got. And so, if it looks cheap, it is cheap. Rule number 2. Yes, sir.
A quick note on 3D printers, that since they're so expensive, the Arlington Library, if you're local, has 6 really high-end 3D printers and they're free for anybody that has a library card to go in and pull stuff. That's how I designed, that's how I printed my Raspberry Pi case, was I just went up there and it cost me like $7 to print that. So
Yep.
it's a really good resource.
And there's a ton of IBM parts and other things like that out there. And yeah, pretty much every library has 3D printers now. In fact, many are also having DLP 3D printers. And that's where you can't tell that it's not a produced part, for the most part, on many of those. So yes, absolutely take advantage of that resource. But everything exists for a reason. So if it's on there, there's generally a reason that it was on there. Right? Just like how we discussed the Rifa caps, what was going on with them. If you can't understand why it exists, there's probably a reason why it exists. And it's usually not a good reason if it doesn't immediately pop out to you. Common problems have common solutions. So when we get into specific systems, if there is a continuous failure or you have a failure, odds are other people have that failure. So there are some noted ones, especially on Commodore 64s and Amigas and Atari ST systems, especially with regard to video output, that are very, very fixable. Actually, just like a capacitor replacement and a bypass, and you're good to go. So with that, now that we have some rules and some guidance to go on off, missing parts. Guess what? Schematics usually exist somewhere on the internet for the thing that you're doing, unless it is extremely obscure, which I'm guessing not many people here are undertaking as their first project, some sort of like prototype K-Pro, then schematics for the thing probably exist somewhere. And you can usually find a service manual, because a lot of the stuff until we get into the mid to late 90s is designed to be serviceable. So there's going to be something out there. So you can also figure out this next part, unpopulated circuits. So we talked a little bit earlier about companies being cheap. Filtering and power are the first things they're going to cheapen out on, because those are some of the most expensive parts that are not required to make the thing functional, right? So now we have an idea of okay, what are some typically unpopulated circuits that are gonna be where you're gonna see on the actual PCB where there are spots to put a bunch of parts. And they'll usually even have some little designation on the silk screen. So the little words on the PCB will actually say what it's for. And you can match that up with the schematic and you can go, oh, this is where they decided not to include this. Or, oh, it's listed as optional. They just never populated it. Now you can populate it. And some other things about modern solutions. Modern solutions to ancient problems they never intended to solve. So some of these are specifically around certain parts being available. So when we talked about low ESR applications with tantalums, a lot of times they put tantalums in because they are low ESR, but you can get low ESR electrolytics now. You can get bipolar electrolytics now. So you may see that they put in some absolutely ginormous, 2 or 3 microfarad film capacitor in there because you couldn't get a bipolar electrolytic at the time. Put a bipolar electrolytic in there. Sometimes you can replace batteries with supercaps. What? And then you never have to worry about corrosion ever again. There are so many little things that we can do with just modern parts that really end up making a lot of these systems work significantly better, especially because the tolerances that are available currently, combined with things like modern regulators, mean that we can have absolutely everything essentially working as the engineer had originally designed, but without having to deal with the realities of the production lines that they had at that time. So, all right, we've got these missing parts. We have an idea of how to populate some of these circuits, build out all these things. What are some upgrades? right? So if you have audio, noise, and display fuzz, we talked a little bit about those issues with your display looking fuzzy or your ground not sounding good. Power consistency. Add a big electrolytic to the main voltage output rail. Add a film or ceramic bypass to that electrolytic. That means that you have nice, consistent, smooth power, even if you don't necessarily have the smoothest or best power supply. So assuming you've already done the work to the power supply doesn't mean that it's running as optimized as it should, especially on some early switch mode power supplies. They have a lot of noise. This kills that noise. If you have ground noise that's going especially through your audio circuits, or ground noise that's affecting your monitor output, so especially if it's like causing all kinds of issues there, add a ground loop bypass. It's a high wattage resistor in parallel with a about 250 volt film capacitor in line with the ground input. So you take the ground input, you put this bypass in it of a big old resistor with a film cap. Cheap is fine, 0.1 microfarad is fine. And then you continue on down the line. That is a ground bypass. It will immediately get rid of any ground loops you have without having to use an isolation transformer. And it's cheap. Great for audio applications, great for output ground for your displays if you're having issues with ground loops throughout your system. And that can be just the way they designed it because they didn't have good grounding. Speed queens, you want to speed it up? Replace those clock crystals. Guess what? They weren't to spec in the first place. What? Okay, but now you can get ones that are within 1% tolerances. A lot of times the older ones are 5 to 10%, and they've drifted over the years. Get your clock crystals in order. Power regulators, again, good power means that things run better, or at least run how they should. Also, basic logic chips. Did you know that some of the old basic logic chips, your muxes and things like that, were actually very slow? Sometimes you, especially on some late 70s equipment, replace some of those logic chips. All of a sudden, everything's moving significantly faster. It just has to do with the speed in which it's able to complete the operations, even though they're really, really simple. You can also add ceramic or film power to ground bypass capacitors. Those are so that you don't have any spinning of your actual processor. A lot of companies cheaped out on it or didn't do it because it was operating well enough. Well, especially if you make that clock crystal really, really clean, that causes some buzzing. So if you add in that little 0.1 microfarad little capacitor across power and ground right next to the chip. If you ever wondered why there was that little tiny ceramic capacitor at the top of the chip, that's what that's for. It stops it from oscillating needlessly. It means that you are going to complete more cycles than you're losing. A lot of people don't realize that their old computers are actually losing processor cycles. And that's what's causing issues, especially with the handover of instruction sets. And finally, clean all the connectors. Use that fiberglass pen, get in there. Sometimes to just clean off some corrosion. Make sure you go in with the Q-tips. Solid connections give you solid results, right? And with that, this is my contact information. Yes, this is my actual email. You can totally just ask me questions. You can hit me up on social media, find me, any of this kind of stuff. And you'll also notice there's a link to the slides right here. So, yeah. Any questions? Yes, sir.
Okay. If I have a 30-year-old computer that looks like it came off the showroom floor, are you suggesting I recap the whole thing?
30-year-old computer?
Yeah.
What's the make and model?
You mentioned 30. That's the reason. I have an Atari XL, 800 XL,
Ooh.
and I have a Apple IIe that I got secondhand from a family friend.
Okay, so the Apple IIe is probably fine. The Atari XL is probably not. I have one as well. It will. Like some of the larger electrolytics on there have started to show their age and are no longer running in spec. Okay. That doesn't mean that they're bad or that they've gone bad. They're just no longer running in spec. Right. And that's going to be much more typical of the large electrolytics, more so than the small electrolytics. A lot of times the small electrolytics are just there to keep the power happy, or they're being used to actually filter the DC out of a signal.
So do I have any ticking time bombs?
Large electrolytics on the XL, the Apple II is probably fine.
The reefa cap in your
Yep.
e-power supply will smoke at some point.
Yep.
Stink up your house.
Yeah. Invest in scented candles. I hope you have a partner.
Well, I'm mostly concerned about, like these battery things that just destroy boards.
So if you're worried about that, a lot of times the batteries, especially in those systems, have a very small trickle charge re-up. You can just replace them with a super cap. It's literally $2. A lot of times it'll drop into the same slot hole, or you can buy one off of Amazon or any of these other ones. And then it just goes away. And you spent 15 minutes, and then you never have to think about it again. And that's the way I weigh everything, is like going, okay, does this thing matter to me? Does it matter to me enough to invest an hour of my time to never have to think about it again? And those things are where I derive value. And I also calculate what the value of my time's worth and how much I enjoy. So for you, it's obvious. You want to save the thing. It matters to you. So when something matters to you, how do you treat it? Do you treat it as something monetary, or do you treat it like like at least your neighbor's dog, right? Like,
Yeah. My baby, yeah.
okay. So take that decision making and that recognition into everything that you do, because those are the things that we have to do as well, right? We have to acknowledge. You're like going, oh, it's stupid if I do this thing and if I do these things. Well, the world is made of stupid stuff. So if something matters to you, treat it like it matters to you. And that's why we're here. That's why this event exists, because it does matter. And like, recognize that interpersonally, and it will make all of your work feel so much better, because you're doing something for you. And that's what this is. You're doing this for you. It saves a thing, but it saves a thing for you, right? Or it saves a thing for someone else, or it feels good, or you're helping, or something along those lines. Sorry, got a little personal there. What?
Oh, that's your kids out there.
Yeah, I'm pretty sure that's them screaming, yeah. But thank you, everyone.
Thank you.